want to take a look at just a couple of other common types of parametrizations that we might encounter. One would be for a cylindrical surface. Remember, a cylindrical surface, we haven't really looked at those in a while. That was when we did this process of extrusion. So this is the extrusion of a plane curve. So for example, if I had z equals x squared, I would, in the xz plane, just draw a parabola, z equals x squared. This equation doesn't put any restrictions on y, so y is free to be whatever it wants to be. So I would extrude this parallel to the y-axis. So I would get something that looked like this. Essentially, I had my parabola, and then I extruded it. So what you're seeing then is this parabola that's coming, sort of curving towards you as x increases. Now you might look at that and say that's a surface in 3 space, and there I'm only using 2 variables to describe it, but those 2 variables don't give me exactly where I am on this surface. They do a great job of describing the surface as a whole, but if I wanted to be at that particular point, I would need to be able to describe the x value, the y value, and the z value. And that's not giving me the information about the y value. So what I would do is I would introduce my parameters u and v. Okay. If I let x be u, then z is u squared. Because here I was able to describe this curve with z as a function of x. It's a one-dimensional curve. I can describe a one-dimensional curve using one variable. So I use one of my variables to describe the curve, in this case that parabola. I'm going to use my other parameter to do the extrusion. So I'm going to let y be v. Now that way, if I take a look, if I had a constant u curve, that would make x and z fixed. So I'd be at some particular x and z location, maybe on the xz plane I'm here, and then y can be whatever it wants to be. So it would be the extrusion of that point, which would just be this line parallel to the xy plane. On the other hand, if v is constant, then I'm at a constant y value. That's when I'd be seeing these parabolas. Those would be my constant v curves. Kind of cool. Now, that's what we get if we extrude a curve. I could also rotate a curve about an axis. So let's just suppose that I have y equals f of x. I've drawn it so that it looks like an exponential function. It doesn't necessarily have to be. So here I'm drawing things in the xy plane. If I rotate this about the x-axis, that's going to sweep out some sort of a surface, and I can try to describe that. Now, for the purposes of describing it, I found it helpful to just draw the 2-dimensional xy plane. So this is not with the standard orientation, but I can imagine that like my z-axis is coming out this way. I'm not actually trying to draw the surface, I'm just trying to say, hey, that's the curve that I'm going to rotate about things. And so then I want to try to describe a point on that surface that I'm going to get. So I'm going to introduce my parameters u and v. Okay. And if I were to let x be u, okay, that's kind of nice. I do need to be careful though. That does not mean that y is simply going to be f of u, because of course as I rotate around, my x value isn't changing, but my y and my z values would. Essentially what would happen is if I'm at a particular x value x naught, then what I'm doing is I'm drawing a circle whose radius is f of x naught about the x-axis in that plane. So if I look in the plane x equals x naught, that's parallel to the yz plane. And what I'm going to see there is a circle of radius f of x naught. Now I know how to describe a circle whose radius of a given radius. I'm going to let one of these variables be that radius times cosine of theta, and one of these be that variable times sine of theta. Except I'm going to call theta v. So I would let y be f of u cosine v, and z be f of u sine v. That way, in the yz plane, I am drawing this circle whose radius is this distance here about the x-axis. So this determines what plane I'm in to be drawing that circle, and then it also determines what the radius of that circle is. Pretty cool. So, bunch of different parametrizations that we've seen. As we start doing stuff with our parametric curves, we'll start to gain some sense of when this parametrization is simpler and when that one is simpler. But you want to make sure that you spend a good bit of time just getting comfortable with this notion of parametrization and being able to understand how to parametrize a given surface that you might have.